All right, so the first three sections of this unit were pretty much solving an equation that has one variable, basically a review of the standard ways of solving the equation. Your one steps, your two steps, multi-steps, variables on both sides. The standard way for solving them is what we've been reviewing, recapping, relearning, reteaching since last week, Friday. First, you do distributive property to get rid of the parentheses. Then combine like terms on each side. Then move the variable to one side if you need to. Then eliminate adding and subtracting, and then eliminating multiplying and dividing. So that is your SOP, standard operating procedure for solving a linear equation. That's your standard operating procedure. So that works if you only have one letter in the problem. That also works if you have multiple variables in a problem. So today our equations are going to have multiple variables. Our equation is going to have multiple variables. So a little bit of vocabulary as we get started here. A literal equation is the equation with two or more variables. So it is a literal equation if it has two or more variables. So you could have equations that have numbers and variables, or you could just have equations that have all variables those are literal equations. Now, everyone in here has used an equation like this before. You've used it in math when you did y equals mx plus b. That's a common example of an equation that you've worked with. You've used it when you've found the area, found the perimeter of something, or found the area of something. So these are common examples of what's called formulas. Those are common examples of what are called formulas. So when you are given a multivariable equation, you have to then be told which letter to get by itself. So they're not going to send you on some blank mission. You're going to be told what letter to get by itself. So you'll be told in the directions, solve for X, or solve for Y, or solve for A, or solve for B. So you'd be told which one to get by itself. You're simply rearranging the problem, solving the equation for the variable that they want by itself. So you're solving for the variable that you want by itself. Plus side, you use the same steps as you would with regular equations. So these steps up here still get used. Those steps will get used. If you see parentheses, you'll get rid of them. If you have like terms, you combine them. If you see adding, you subtract. If you see multiplying, you divide. Those rules are still the same. So the best way to navigate through this is to simply look at examples, look through examples. And that's what we'll spend our time doing today. Any questions before we continue? Handle your business. All right. So we're going to start off baby steps and then work our way to harder and harder problems. So let's start with example 1. So example 1. So notice right off the bat, they're telling you to solve for x. 14 equals x divided by y. 14 equals x divided by y. So since you want to get x by itself, that means you need to get rid of y. You have to get rid of the y. So first we look at the problem and see what is y doing. So notice in the problem, right now, you're dividing by y. Right now you're dividing by y. So in order to get rid of it, you have to take the opposite. So right now you're dividing by y. What's the opposite of division? Multiplication. So that means you're going to have to multiply both sides by y to get rid of it. Multiply both sides by y to get rid of it. So multiplication and division are opposites, so the y's drop out. Fourteen times y is 14y. So 14y equals x. So you look at the problem, you ask yourself, is x by itself? Yes, it is. So that's your final answer. So I want you to notice your answers are not going to be just numbers by themselves. Not in this case. They're not just going to be numbers by themselves. The other letter will still be there. The problem is just being rearranged. Any questions with example 1? So, when you are solving these type of problems, if you have more than one variable, the first thing you're going to have to do is look at the problem, figure out what is already happening. Figure out what's already happening, and then start solving the problem. Figure out what's already happening, and solve the problem. So, even if you know that either A, you're not going into anything that's going to involve you to do algebraic math in terms of a career, or if you're not going to college right off the bat, or so on and so forth, you are going to come across problems that are going to require you to work with more than one thing at once, that are going to require you to multitask, or just simply require you to work with a complex problem. Those things are going to happen over the course of your life. So you have to know, what are you working with so that you can figure out how to solve the problem. That's life. So, example 2. Again, solving for x. X minus y equals 20. So again, we want x by itself. That means we need to get rid of the y. We got to get rid of the y. So right now, what is y doing? So we want x by itself. What is y doing right now? Well, it's already subtraction. So right now, y is subtracting. So that means to get rid of it, you're going to add. So you figure out what it's doing now so that you do the opposite. So you're going to add y to both sides of the equation. Because again, we want to get rid of it. So the y's drop out. Adding and subtracting their opposites. So those drop. X equals 20 plus y. So can I do anything with 20 plus y? Is there anything I can do with that? I think I heard 22. I'm just trying to figure out where the 2 came from. Ah, so 20 plus y, 20y. That means multiplication. So 20 plus y, those are not like terms. So you can't do anything with that except leave them like it is. So 20y means multiplication. Means 20 times y. So if you have a number plus a variable, there's nothing you can do with it. Yeah, I'm sorry. Don't be sorry for making a mistake in thinking. That's a mark of an incredible student, incredible scholar. I did a lot of thinking and getting stuff wrong yesterday in my graduate school class. So, teaching what? So I did a lot of guessing and thinking and answering questions in my graduate school class yesterday. Graduate school. I'm still in school. I'm working on my 6th degree. Yes, number 6, and I still have number 7 to get. Yeah, 7. Again, if you want something, you don't let anything, anyone, anytime, any place stop you from getting it. Otherwise, you have no one to blame but yourself for not getting what you want. So, that is my word of wisdom for today. Problem 3. Problem 3, we're going to solve for y. Solve for y means we need to get rid of the x. Oh, don't worry, Derek. That's what it's going to be. That's what it's going to be. I've already set my target date, 2025. So I got 4 years. So 4x plus y equals 5. So I want to get y by itself. That means this 4x has to go. 4x has to go. Subtract 4x from both sides, absolutely. So 4x minus 4x is 0, so it's gone. Steve, you got a question? Oh, go ahead, finish it. We're gonna have what? So he says y equals x. Go ahead, Neil. That sounds a lot better. So here's the problem with it being x. 5 doesn't have an x attached to it. So therefore, I can't do 5 minus 4 because the 4 has an x, the 5 doesn't. So remember, the rules for combining like terms still apply. So the rules for combining like terms still apply. They have to have the same variable and they have to have the same exponent. So those rules still apply. So again, this is where I want you all to make mistakes. Making mistakes here is fine. Making mistakes here is fine. So let's try another. So we're still going to solve for y. Still solving for y. Y minus 4x equals 12. So we want that y by itself. So we want y completely by itself. So what can we do first? Minus 4x, absolutely. So minus 4x, if we take the opposite of it, is adding 4x. So see, just remind you, this you can't do 12 plus 4 because the 12 doesn't have an x. So you have to leave it as 12 plus 4x. Then you can add it. So if this was 12x plus 4x, then it would become 16x. All right, so we move the x over, but we still don't have y by itself. That 2 has got to go. We got to do something with that 2. But so right now, 2 is multiplying times y. So to get rid of it, you need to divide it. So everything gets divided by 2. If you divide one thing, you divide everything. If you divide one thing, you divide everything. So 2's drop out. 12 divided by 2 is 6. 4 divided by 2 is 3x. So y equals 6 plus 3x. 4, you could rewrite it as 3x plus 6. It doesn't make a difference. Doesn't make a difference. All right, so questions 3 or 4? Questions on 3 or 4? All right, so let's do 2 more, and then we'll take a short break before we look at some more of these. So example 5, solve for y. So we're still looking to get y by itself. Still want y by itself. So the first thing, for me not to be writing in spot where it's interference. So, what's in this problem that's showing up for the first time? So something's showing up for the first time in this lesson today. Those aren't absolute values. You have your glasses on? Those are parentheses. So if we have parentheses, what are we going to do first? By doing what? You're going to have to distribute. So if you see parentheses, you have to distribute. So y plus 2 equals 3 times x is 3x. 3 times negative 1 is negative 3. Did we get y by itself? No. But we got rid of the parentheses. So we're still going to get y by itself. So something with plus something's going to happen at plus 2. That would be a subtraction from both sides. So that would be a subtraction from both sides. So y equals 3x. So we have negative 3 minus 2. So that gives you minus 5. So sometimes you'll have to distribute in order to get the problem solved. Again, every problem is different. There is no cookie cutter, one size fits all problem. Every problem is different, so you have to look first to see what you would do. Or what's there and what can you do. All right, so we have one more example and then we'll take a short break. So example 6, we're solving for h. So we want h by itself. So we have h, we want h by itself, and you've got L and W sitting there. So we've got to get rid of the L and we've got to get rid of the W. Any ideas? If you're stuck, let me give you a hint. What is L currently doing to H? Is it adding, subtracting, multiplying, or dividing? What is L currently doing to H? It's multiplying. Remember, anytime you have variables smashed next to each other, that's multiplication. So right now, L is multiplying. How do you get rid of multiplying? Divide. So divide to get rid of it. So we're going to divide both sides by L. So B divided by L is equal to WH. You still need H by itself. Now what do we do with W? What's the W doing? Think about what you just did to the L, and you're going to have to do the same thing to the W. W is also multiplying times H, so you're going to have to divide that too. So you have L and W and H. So now H is by itself. So there's one thing I want you to notice. But again, this is a more complex problem. You divided twice. You divided twice. You divided L and you divided W. It would have been real nice if you could have just did it in one step and save yourself some time. The plus side is you can do that. If you know that you're going to be dividing two different variables, you can do them at once. So instead of doing this in two steps, you could have did it in one. L and W are both multiplying times H. You could have did it in one step, gotten them both at the same time. And there's your answer. So, does it matter which way you do it? No. If it made more sense for you to divide it twice, divide it twice. If it's easier for you to divide it one time, divide it one time. Again, you know yourself better than anybody else. Question on example 6 before we take 2 minutes. All right, finish off our work today. So now we're going to solve this out in word problem formats using formulas that you're familiar with, so on and so forth. So problem 7. Calculating simple interest. So I equals P times R times T. So we've done simple interest before, earlier in the first semester. So I equals PRT. P is the principal, your initial investment. R is your interest rate. T is your time in years. So simple interest, most bank accounts use that. Most loans that you'll have, hopefully you don't have that many, use simple interest. So this is your interest formula. We want to get R by itself. So that means the P and the T have to go. The P and the T have to go. So problem 7 is very similar to problem 6 that we just solved out. 3 variables next to each other means they are all multiplying times each other. So if I want to get R by itself, what do you have to do to the P and the T? Think to yourself, how do I get rid of multiplication? How do I get rid of multiplication? Yeah. P is currently multiplying. The opposite of multiplication is division. So you're going to divide by P. T is currently multiplying. The opposite of multiplication is division. You're going to divide by T. So the P's drop out, the T's drop out. I check, make sure R is by itself. It is. That's solved. So that's solved for. Any questions? Part A. Again, the main thing with a multiple variable problem, if you have more than one variable in the problem, the first thing that you have to do, is look at what is already happening in the problem. Because in order to solve it, you got to know what's going on. So, part B. Using your answer from part A. So, take your answer from part A, move it on over. Find the interest rate for an investment of $1,500 that earned $54 in simple interest in 1 year. Convert your final answer to a percent. So, you have I, P, and T. So your investment of $1,500. So where is the $1,500 going to go? So where do we put the $1,500? Is it I? Is it P? Is it T? Is it R? Which one is it? If you put it in the wrong spot, that's going to be a problem. I know Leah, Jalen, and Steve aren't the only ones here in class today. Probably got someone on their PS5. making bacon and eggs in the kitchen and didn't invite Miss Weisskopf and me. That's not I. Think about what it said. Find the interest rate for an investment of $1,500. P is the principal, your initial investment. So that's P. So since the problem told you time in years, you leave it in years. So that's 1. That earned $54 in simple interest. So simple interest is your I. So now we've assigned everything. Now we just got to solve it. So 54 is 54. 1,500 times 1 is 1,500. Let's let the calculator do a little bit of work. 54 divided by 1,500 is 0.036. So that's a decimal. Your problem specifically said, convert your final answer to a percent. So how do you change a decimal to a percent? Twice to the right, or multiply times 100, and that gives you 3.6%. So again, the primary thing that you need to do when you're given any kind of problem or given anything to sign, well, definitely if you're given something to sign, read it. If you're being asked to sign something, read it. Trust me, and I'm guilty of the same thing. All of us, when we download an app, they normally have that one page that we just scroll to just to get to the bottom. We click, we agree, so we can go use whatever app we want to go and use at that point. All that stuff, once you click agree, even if you read it, even if you didn't read it, you now are held to that. As you enter adulthood, anything that you have to click agree or sign, you better make sure you read it. Because if they do you dirty later, they're going to tell you, oh, well, you signed saying that you agree to it. You know what you are at that point? SOL. Let's do one more problem, we'll finish up here. The speed of an object is measured using the formula S equals D divided by T. D is the distance, T is the time. So it's your standard speed formula. You want to figure out how fast something's going? Take the distance it traveled divided by the time the object is moving. So S equals D divided by T. I want to get D by itself. So the T has to go. So how do we get rid of this T? Multiply it on both sides. It's already dividing. T is already dividing. You do the opposite to get rid of it. Do the opposite to get rid of it. S times T, so, or T times S, whichever one you prefer. So if you take the speed times how long you're traveling, that gives you your distance. Your speed times how long you're going to travel, that's your distance. So now let's use it. Using your answer from part A, find the distance a car traveled if it was driven 0.45 hours at 70 miles per hour. So they told you how long you drove and the speed that you're driving. I'm driving 70 miles per hour. Hopefully not, knowing that there's ice all over the ground. For 0.45 hours. So how far did you go? So 70 times 0.45, how far did I go? $31.5 miles. So that's about the distance from Flossmoor to LaGrange, Illinois. I only know that because I worked the softball tournament, the indoor softball tournament up there this past weekend. Yes, I'm always finding myself into stuff. I don't know how to sit down somewhere. Oh, those were money moves. I made $500 that night. Look, I've always been raised on the model of if you are good at something, never do it for free.